Hello. Some of you asked me about the solution to the last quiz, about the last four steps. So here I'm making a short video about that part. First of all, is I imagine this is why. Okay, first, why this is true. Okay, why is this true? The reason this statement is true is because definition of a logarithm. Okay, so what's the definition of logarithm? Okay, so I'm going to explain this from, so here I'm going to explain to you that why this is true. Okay, so why is this true? Why is this true? Okay, all right. And then I first explain this. The definition of a logarithm is this. Starting from log base 2, for example, if I have log base 2, of bologna, okay? So this is really omega, so I'm going to call it bologna equals to triangle, okay? What does this mean? Okay, example such as if logarithm base 2 omega, so if this is 8, right, this will be 3 because okay, by definition of logarithm, so let me find the double arrow, and let me find a double arrow here. I will find a arrow with both directions right here. So this means 3 power 2 equals to 8, right? So 2 is powered by 3 is equals to 8. And by the same reason, the definition of log base is defined as the triangle power the 2 will equals to omega, okay, or bologna. So 2 raised to the power of triangle, okay, it would be equal to omega, okay, or this is also my bologna for the moment, okay. So you can see this is a relationship. This is a relationship. From this relationship, right, 2 raised to the power of triangle is, omega. I'm just going to copy this one more time, so still the same thing, and replacing the triangle by its equal. What equals the triangle is log base 2 of omega. So that's going to be a logarithm identity. Okay, so this is a logarithm identity. Now, this is for base 2. What if for base e, right? For base e, so what will be, suppose I change the base to log base e. So this is going to be ln, right? And the other side, the base e will be changed to, base 2 will be changed to base e. Okay, so log base 2 was changed to log base e. So this will be e to the power of triangle equals to omega, right? It's a similar relationship. And we have a shorthand notation for log base e, which is ln. So in this relationship, for example, okay, let me give you an example. Suppose this is the e squared. Okay, this is e squared. What will be triangle? Triangle will be 2 because e powered by 2 is e to the power 2. Do you see that? Okay, so this is the definition for log base e, natural log base, that a natural log, okay? Log base e is called natural logarithm. So now here, we're going to do the same thing again, okay? So triangle is replaced by its equal. Its equal is ln base omega. Ln omega. Okay? So that's where this identity comes from. That's where this identity comes from. So that's why in this step, right? When omega is y, right? When omega is y, we will get the following. Omega is y, and here's y. So that's what we did from this step, okay, to the next step. We have applied that same property, okay? The next step, however, from this step, okay, so let me draw some arrows here, okay? So from this step to the next step, what's being used? What we used here, from this step to the next step, we used this theorem. We used the theorem, okay? What does that theorem say? Okay, that theorem says, suppose we are taking a limit. Okay, x approaching a, okay, f of g of x, okay, and g of x has a limit, right? G of x has a limit. So that is as limit x approaching a, g of x is equals to b, Then remember, g is the input for f, okay? So when we take a limit like this, we're taking limit of the output of f, okay? So g is the input, f of the parentheses is the output. This theorem says you can take the limit from output and on input, and you will get the same limit. So that theorem says, that's how we say this theorem is about when we take a limit like this and f is a continuous function, the limit can go across f from output into input. So that's what this theorem is about. So in our case, what is f? Our f, okay, in our case, of course, is x approaching 1 from larger than 1. Okay, so what do we have here? The function we have is e to the power of, say, e to the power, I would say, I'm going to use a notation. I'm going to use, let's see, let me use another note. Use a heart, right? I'm going to use a heart. If you look at E function, right? I mean, if you look at the E function, the input is a heart, the output is the whole of it, right? So this theorem says, well, since the heart is ln y, okay? Is the hard part has a limit, so we can bring that limit, okay, across the continuous function. E is a continuous function, and on heart. So the limit we took from the output, and now we take a limit of the input, we will get the same limit. And in our case, okay, what is the heart? The heart is ln y. So that's how ln y get to be here, ln y. And the limit, and this limit, which is in the exponent of e, is equal to -1. So that's how we get to e to the power of -1. Okay, so that's the whole explanation. The first part is about how we get this, right? This is identity, this is logarithm identity, okay? And from the definition of logarithm. And secondly, we're using this theorem where we learn it in the sections of continuous function. I hope this helps. Otherwise, let me know and we can have some further discussions. Thank you for watching. Good night.